Okay, hello guys. Today we are talking about the basic terms of domain, range, and notation in function, okay? So let's understand what is a function. So you can just consider a function as a machine, okay? So maybe here we have an input x into it, and the machine will performs a specific role and will get a product, okay? So you're just trying to understand like this. So because here it produces exactly one output, we can reason that as y or fx, okay? So we can consider here, maybe for positive negative square root x, you can consider as first, or like at the very first beginning, that x is an input. And after the function, it forms a positive negative square root x, okay? That is how we can understand it for this and how to try to solve in this, okay? That is this. And we can say here, and for domain and range, we can consider domain as a set of possible inputs or x values of the functions, okay? A range means a set of all possible outputs or y values that the function produces. So if you draw a graph like here, maybe you can just consider like for a quadratic graph like here, we can say x can choose any values among the x values, or you can say it can choose zero, positive values, negative values, or even other values. And here the y values can chosen like we can consider as for like the only bigger or equal than zero, okay? That is it. Okay, so then if we can how to calculate this for such problems, okay, I hope you can just understanding for the domain and range. So range here means for a set of possible outputs for just for y values, okay? That is the difference between this. And for example, like here, we can just trying to understand what is for the function fx. We can say here fx equals 2x plus 3. That means each output we first times 2 and then added with 3. And that's the final answer for the output. And also for here, the function x, it becomes 2x plus 3. The same meaning for this, but it's another kind of notation, okay? So that is a standard function. And here's a mapping notations. Also, you can just trying to use it either when you're in the task, okay? That is it. So most of the time we are using the first kind of notations, okay? And let's move into the restricted domain. So maybe for here, maybe for fx equals to x squared, sometimes the problem will say that there is a restricted domain like x bigger or equal than 0, okay? So that is a domain. And we can also say that it's a range because for fx, here you can just try to draw the graph, okay? So even though you choose x bigger or equal than 0, that here it represent for the purple region, right? Okay, so you can also find purple region is upper the x-axis. Okay, so that means the y value always bigger equal than 0. So you can just set fx or y values bigger equal than 0. That is a range for the function. Okay. So for example, like here, the problem is find the range of fx equals to x squared minus 4x plus 3 for the domain of x, okay? So we have already know that for the function, the graph here is like this, is a U-shape, right? Because a bigger than 0, right? A bigger than 0, that means it is a U-shaped graph, okay? And the domain here is x in the real range, also we can just try to set, oh, maybe here we can choose any values of x. So we're just trying to first write them down as a square form, like x minus 2 squared minus 4 plus 3. So final answer can be written down as x minus 2 squared minus 1, okay? So like I said, for the function, the vertex here is for 2, negative 1, also means the smallest value for a function is negative 1, okay? So you can say, okay, so now function fx bigger or equal than 1, that is a final range for the function, okay? That is it. Okay. And also for another example, like here is that for a range for gx equals to 2x plus 1, and the domain here is for 1 smaller equals than x, smaller equals than 5. So you can just try to solve in this. First, you can put x equals to 1 into the gx, it becomes g1 equals to 2 times 1 plus 1, right? That is for 3. And you can also put x equals to 5 into the function that is 2 times 5 plus 1 equals to 11. So you can say here the gx is bigger equal to 3 and smaller equal to 11. That is the range for gx, okay? That is it. And here is the exercise for you. So if you want to try yourself, you can just pause the video and do yourself. But if you want to follow with me, you can keep on going, okay? So let's move into the first problem. So the problem is that find the range of the following functions. The first is for x squared plus 2 for x in real range, right? In real domain. So we can just try to draw the graph like here. Right? So vertex is 0, 2, okay? So we can say here, the function's minimum value is for 2. So we can say, so y or fx bigger or equal than 2, or you can also say that bigger or equal than 2 is the range of it, okay? And for second problem is that actual x equals to 1 over x minus 2 for x bigger than 2. So here, the denominator can be considered as bigger than 0, so the total value can be considered equal to 0, right? Okay, so we can say the range here is bigger than 0. And then for the last problem, you can just try to draw the graph. So the graph is like the vertex is 3, 5, and here is like this graph. So x is for 0 to 6. We can just try to understand like this way that is a domain for this. And you can just calculate the range because it is a symmetrical graph among x equals to 3, right? So this value is for 14, and this value is also for 14, right? Okay. And the smallest value here, you can just put 3 into this, 3, 5, right? So we can say y's range is from 3 to 5. That is a final answer. Okay. That's the topics for today's our lesson. We already learned about domain, range, and notations. Hope you can just understand it for all of this. Okay, so see you next time. Bye.